Hey,
Hey Harvey,
hey, how's it going?
good. How's it going for you?
Good. Where are you located?
Romania.
Cool.
It's a it's a so-so time for me.
Yeah, we're located here in Cambridge. It's very hot right now. It's like 90 degrees outside.
The Actually, I haven't stepped out of the house today, so I'm not sure how the weather is.
I know that feeling.
Yeah. So I've been looking over the links you sent me on Slack, but I see that you have a huge refactoring going on.
Yeah,
Yeah.
we're doing Scott Weiss can talk more in depth about it, but basically we're taking everything we learned in the last few months and just simplifying the abstractions in the code base so that hopefully it's much easier to extend from the open source community. Like the code right now, it's kind of difficult to locate where the different features live. I think the code organization also leads to some instability issues with like the reconciliation logic. But I think post refactor, a lot of those issues will be cleared up. Hopefully all of them.
Okay, that sounds great.
Yeah. We're also looking to write up some documentation about the architecture of the system and just some different resources to help folks who are interested in contributing open source, making it easier for them to make their first commits and stuff.
Okay, that sounds great.
Yeah, I think we're waiting on a few folks to join. Let me ping Betty. Oh, there she is.
Hello.
Hello.
Okay. Let me just share the link of the meeting in the chat. Okay, 1 second. I'm trying to see if we can record in gallery view. Then we can go from there.
Somewhere between spinach and cap.
All right, so we've got solo side, myself, Harvey, Scott, Aton, and then Cisco folks. I apologize if I pronounced your name wrong. Is it Mihai or?
Yeah, that's right.
Okay, Mihai, John, good to see you again, and Pavan and Dominic. Hello.
Hello.
Awesome. So,
Morning.
good morning. Let's see. We had a. Oh, we've got a. Dominic, I'm moving your rabbit hole question. I like how you named it that in here, but I got to move that back up. move that up to this week's meeting. Oops. All right. Let's start with the first here. We've got some, so we've got a couple things, a few things here. Discussing additional capabilities with respect to workload discovery. There's a high-level proposal, in-depth proposal. Then there is a question from Mihai in Istio to AppMesh Federation, and then the question we didn't get to last time from Dominic. So let's go to that first one, workload discovery. And John, you made that proposal. Would you like to walk through?
Oh, okay. I'm sorry. I thought you were going to go to Dominic's. The way you said it, I thought maybe you were covering Dominic's question first. So sorry about that.
No, all good.
So let's see. I don't know. Let me see if I can share. If not, you can pull up.
Let me know if you can, and I can update so you can share.
Yeah, let me see. Just give me a second. I'm not a huge Zoom user.
I'm making you a co-host so that you should be able to share now.
I think in
Oh, okay.
2020, we're all huge Zoom users.
Well, we have a product called WebEx. So,
Oh yeah, WebEx.
so I think this will be a little bit both Pavan and I kind of talking through this, and we can figure out how we go. So we introduced this discussion on Slack, and I think Christian specifically suggested we bring it up here. So that's what we're doing. And I'm going to give a little bit of a background. So what I have here in sharing, you're able to see what I'm sharing, I assume?
Yep, we can see it.
So a lot of this is kind of comes out for some of our work on network service mesh, or what we'll refer to more commonly as NSM. It's a sandbox project in the CNCF. It's something that Cisco and a few other contributors, like actually you can see some of the other contributors on the slide, VMware, Doc, AI, and some others contribute to. And we've been doing some work with NSM, and we've been doing some work with NSM and service meshes, and that's where some of the justification or desire for this stems from. So again, I'm linking here publicly available stuff. The first one and most important one to understand, probably if you're not familiar with network service mesh, and the one that kind of spawns some of the thinking about how we inject other types of services other than pure Kubernetes services into Service Mesh Hub, is that network service mesh has the capability of injecting multiple interfaces into a pod. And typically, for most of its services and use cases, it will do that. So there will be a CNI interface and an NSM managed interface, as I'm sharing in this slide here. So that presents a need to, when you're talking to envoys and stuff like that, that presents a need to sort of be able to expose to Envoy the fact that some of the services sit behind the CNI and some of the services sit behind the NSM managed interface. And for the most part, Envoy doesn't really care with respect to that, as long as it's presented to in its XDS data. It's happy to just send the packet based on the XDS rules out to the stack of the pod, which then effectively just does the normal thing with routing and IP tables to send it to where it goes. So I don't want to get too much into the network details. The main thing that we want to have a discussion with you about is the fact that, you know, even if we don't even if we don't deal with this maybe specific topology or this specific use case, there are use cases where we'd like to talk with you about how Service Mesh Hub can do service discovery specifically, maybe workload discovery. That's a little bit maybe second order discussion. and not have it be tightly bound to like Kubernetes. And I know you guys are dealing with this problem anyway, because you're talking about VMs and consoles and other types of things. So I know you're generally dealing with this, but we wanted to make sure we convey that the use case might be even broader than you're currently thinking, okay? So that's the justification. Again, I probably don't want to spend too much time on the justification. We can let Pavan talk a little bit about some of the ideas we had that we could explore with you as to whether they make sense or not, or whether they want more content or details on them. My other links here are to some NSM interdomain, which talks a little bit about how NSM, again, this is directly from the Network Service Mesh repository, about how they deal with interdomain and floating interdomain to interconnect things cross-cluster, and that's where the tie-in with some of the work you guys have with Service Mesh Hub. And then there is some more detail in a presentation that Tim and I gave at NSMCon last year, giving a little bit more detail. I think in a general level, you can probably get the gist here of this, what we're thinking about without actually having to go to these links, but they're there if you need them. So
I'm curious about those
questions?
links. Can you paste that, or the link to that gist in?
It's actually, I added this, this gist is added to the meeting.
Oh,
notes.
okay, perfect.
So you should be able to access it directly from the meeting meeting notes.
And I'm just adding your name to the top of the note.
So is there any questions sort of on the background and the use case before we talk about some of the possibilities that we were exploring and get some feedback on those possibilities?
No, I don't think so.
Okay, so Pavan, do you want to kind of maybe go through some of your ideas?
Yeah, let me share my screen.
Oh, Pawan, I might need to update you to. There you go. You should be able to share.
Thank you. Chrome. Can you see my browser?
Yes.
Yes.
Okay, great. Yeah, as John was basically saying, given some of our projects with NSM, there is like a whole variety of networking capabilities added to some of the pods. Whether be it a new interface, or a direct, a tunnel from one pod to the other, like a VPN, for example. So we basically just, in general, we're discussing how could we do, service discovery, we basically had an initial chat on Slack, and I know you guys have already been, thinking about some of these possibilities. So just wanted to, just go through what we were thinking and get your feedback. So the short-term workaround which we had was, if we had any sort of services which were in Kubernetes service, but sort of like a service entry in Istio, for example, and if we wanted SMH to pick it up, then we could write a simple controller which would manually push a mesh service object into it whenever there is a new service being added. And this is basically a short term, right? And it doesn't require any of the SMH code to be modified. And it seemed okay until we have like native SMH capability which does this. We could just try this out, see how this works, and get some feedback and things like that. So this is what we are currently just trying this out as a POC. And some of the other two proposals which we had in mind.
But Pavan, before you go on, I just had one question. So for the solo people on the call or anybody else. Do you believe this would work, or is there some more tight coupling that's needed between the service object and the workload objects that we'd have to manage and change something within the SMH code itself?
So can you show the content of the mesh service? Like what, because this is not backed by a Kubernetes service, I think.
Yeah, it's a has like a few different custom fields which we are okay, just adding them as labels, but we are trying to make sure that whatever manifest we are creating ties in well to whatever you guys expect, and not push anything which currently SMH doesn't accept. So it's basically general. I might have something which I'll share after I stop this recording in the GitHub document. Sorry.
So under the hood, all the mesh services have to map to either a Kubernetes service, or we'll need to create, in the case of Istio, a service entry for them. So it just requires us to know things like the host names, IP addresses that back the service. There isn't really much more that we need. So it's a question of, and we haven't opened that up yet to anything other than a Kubernetes service. So there's definitely going to be some changes that need to happen there. But I think we have a clear idea how to represent anything that's going to be a service entry. I think the only question is, do you want to be manually providing those IPs or DNS names in the mesh service? Or do you want Service Mesh Hub to be able to resolve them by allowing Service Mesh Hub to actually read from your service registry directly?
So that's, you jumped ahead. So so just to summarize, you're saying that this approach probably would not work without more substantial changes, even as a short-term proof of concept. So we'd have to, I think that's what I'm hearing.
In the current form today, Service Mesh Hub is only supporting Kubernetes services. However, we have plans to expand it to support like a generic IP or static DNS name. And from there, you would be able to support this. And then there's a question of, would you even want to go one step further and allow it to be more dynamic rather than providing a static host name to provide a pointer to the service entry in your registry that Service Mesh Hub could fetch directly?
Yeah, so that's perfect. So we didn't really want to do this. We were trying to just prove that, find any skeletons, and it sounds like there are some. So Pavan, continue, because Pavan is really getting exactly to what you're suggesting, Scott.
Yeah, I guess great segue. So we initially thought, okay, for us to actually step out of the POC mode and actually have like a proper service registry client, if you will, in SMH itself, then what we could do is write a gRPC client which would basically put the information without SMH actually needing to poll, for example, and all of this obviously would be some sort of a service entry type object which would get registered in SMH, and SMH would be able to sort of resolve this. So this is sort of one client interface plugin which we thought if SMH had the capability of hosting some plugins which would basically sit in the repo or somewhere else, which could tie in with your current service discovery, this could work. But we had another idea, as you suggested, Scott, where service registry client, if you basically had that implemented in SMH, it could basically poll to n number of external registries which are out there. It could be etcd or Consul or anything like that, and constantly keep track of whatever service entries, which could be Kubernetes external, VM, anything like that, if the cluster wants to keep track of them. And the client could basically get updated whenever a new entry is added to one of the clusters and create a mesh service object, so that SMH would be able to discover and sort of use it as a regular Kubernetes service. So this I think is more general, and the first approach which I just shared is sort of Cisco specific, but with this general approach, we feel it doesn't really tie into some of the NSM needs, but rather like it would act as a general service registry client which will work with anything basically. So yeah, this is just like a general teaser which we have thought of, but we can fill it up with as much detail as possible if this could be of interest. But anyway, this is all I had to gauge some interest. I'm sure you might have some of this already in the works. Wanted to hear what were your thoughts. Does this make sense? Any questions?
Yeah, so it's not totally clear to me. The service registry client, I assume, would be specific to the type, like we would have a different service registry client depending on the service registry that you're using, that you want to
Yeah,
plug.
I mean, for Istio is a bit of a outlier in this case because it doesn't rely or use like a general purpose service registry like console, which Linkerd and AppMesh can hook into. So I guess for Istio you might need a custom entry, but with everything else, you could just say we support console, for example, and any service registry entries which you want to be discovered, give us your console access, and we would be able to discover them automatically.
Sure. The way that I would say now, I don't want to nail us to a particular implementation because we're not up to it yet. And I think it's flexible, but based on what we've already done in Glue, what I would say is we'll probably have a different type of mesh service. So we have one that's backed by Kubernetes. Kubernetes you can consider as a service registry. So we've got a Kubernetes one, we've got a console one, we can pull from other sources. And essentially that the mesh service will be the abstraction, the unified abstraction on top of whatever service registry that you pulled from. And we should have something where it should be easy to plug in or extend Service Mesh Hub with additional types of registries so that we can pull from those as well. But I think that what we would like to do ideally is follow the same model that we've already put down for Kubernetes. So if you consider Kubernetes to be a service registry, we are able to fetch DNS names, endpoints, et cetera, from Kubernetes. We can do a similar thing with console, Zookeeper, etcd. It's all how the client is implemented. And then as far as wiring in the underlying mesh, with Istio, the path is pretty clear on how to do that via service entries. I'm less familiar with console, again, you can actually extend the registry itself. So there's like a kind of a separate conversation because console it's both a registry and a mesh. And then with Linkerd and others, I'd be interested to see what's possible there. But it depends on the mesh.
Yeah.
Scott, regarding I know this has come up a few times on Slack and in the meetings that some of those extensions are in the works. Is there a way to see what that means? Or, I mean, you mentioned the Glue a few times. Is it just going to look at what you do in Glue and assume that the current plan of record is to follow that rough model? Or is there other, information or pointers that you have on how you're going to pull that into here?
I think what it boils down to is what are the pieces of config that we actually need to supply to the mesh in order to enable routing to a service that's entered into one of these registries. So if we think of like the minimal set of data, so we might need some IPs, some DNS names, some ports, we may want labels, etc. Like similar things that we get from Kubernetes. If we have that data available to us, It's just a matter of representing it in a way that's convenient for users as well as that fits the model inside a Service Mesh Hub. I do think that Glue, since Glue has already addressed those, I mean, particular with console, that Glue can use console as a service registry. It can also treat EC2 as a service registry. So it can actually look at EC2 VMs and using, user provided labels can, do service discovery for those VMs. It's really a flexible model. I think the point is, where we want to learn from Glue is that it's an extensible model where, we have something like the mesh service where we can plug in different service registries on the back end, but once they get funneled into the system, they all get treated the same.
Okay.
I think I saw somewhere that Linkerd supports console out of the box. I might be wrong, but it seemed like a lot of the service meshes are trying to use console for service discovery. I know console connect is another service mesh, but it seemed to be like one of the top used sort of external one out there.
Yeah, we can definitely use console as well.
Right.
I think that should be no problem.
So I guess the question then at this point is how do we want to proceed on this? Do we want to provide a more complete proposal? Do we want to create an issue? Do you want to digest the pointers we have for a day or two and respond on Slack? How do we address this general need? I mean, is it something we've got a roadmap? You could have any number of thoughts, of how we want to proceed on this. So we're just trying to understand what are the next steps that we ought to pursue.
So the only thing I would say from the engineering side is it would be great to get a very specific set of requirements down and maybe like a user story or two, like as a user, here's what I would like to be able to do. With a concrete, like let's pick a concrete registry to go with. It sounds like console might be the one that, fits the largest set of use cases. And then, we can come back and, have a design proposal of what that would look like in the API, user experience, and take it from there. How does that sound?
Yeah, it sounds okay. I guess, I mean, I think that's probably a good first step. It comes around, I think, at the end of the day, we have to find some way to also marry this with some of our network service mesh work, but that doesn't necessarily mean that has to come directly in and be exposed to Service Mesh Hub in any way. There could be intermediates like console, but that's one of the things we want to figure out sort of at the end of the day. So I think, maybe addressing a little bit, how you do this with something like console. I mean, when I say you, I meant the community you in that, response might be a good way to sort of see how this plays out. Pavan, what do you think?
Yep, no, sounds good. We were actually, John, Mihai, and some of us were discussing if, Solo want us to collaborate and work together to implement this. We would be, happy to do it. Just wanted to see, would there be any chance for Cisco to get involved or something like that. So.
Yeah, I definitely think that's a good idea. Edith is on the phone here, and she can weigh in as well. We would need to coordinate. Yep.
Yeah, hi guys. So actually, I am talking to Vijay tomorrow, the day after, so we'll be able to set up some time more for us to work together. I think that it makes sense to kind of like start doing a bio, kind of like a weekly meeting or something like that we can actually sync up, can help you, add you to the repository, see how we actually contributing closely together. And yeah, definitely, kind of like do the design together, make sure that you guys can, contributing, or we can help you contribute, or whatever we can help.
Okay.
Make a lot of sense. Yeah.
Yeah, that sounds fine.
Fantastic.
Perfect.
Yeah, that would also be very helpful for us because I think we want to consider the extensibility points in Service Mesh Hub. We're pretty close, I would say, to finishing the current refactor, and we'll be ready to open Service Mesh Hub up to more contribution and scaling it horizontally in terms of more features, platforms, meshes supported. So being able to collaborate with you guys would be excellent for us as far as actually finding what are the desired integration points and how can we make it easier in terms of the code and the contribution workflow to make that easier, smoother.
Okay, sounds good.
Cool. Do we want to, looking at the community notes, do we want to go back and address what was the question about AWS AppMesh?
Yeah, the Istio to AppMesh Federation was the question.
I think Edith has some.
Yeah,
thoughts on
yeah. So
that.
I mean, yeah, no, we own it. The only thing is that we probably it's just that because we re-architect the code. So we wanted first to finish the re-architecture because we felt that if we put a lot of stuff on an API that is changing, it would be problematic. I think right now we have everything, like, right, Scott, like everything in place, so we can actually extend it to federation between meshes, and we have a prototype working. We just mainly to actually make it more clean and beautiful outside. Yeah, I mean, can you be more specific about what the question is? Just they're interested in us adding the support, or is there a more specific question?
Well,
Yeah, can you comment?
yeah. So I'm with John and Pavan and everybody else from the Cisco team. So my business case is is the same they were presenting, where we have these workloads in different Kubernetes pods and clusters, and maybe they are in different meshes. Then we'd want to make use of the mesh capabilities to connect to these pods, and I'm trying to figure out what's already there for possible Istio to AppMesh connectivity, given the scenario that John already presented.
So let me also add on Mihai's behalf. So Edith, I know you've talked to Vjoy in the past. So this is all related to some of our discussions that Vjoy has been, driving with us as far as what's most important to work on, and what he's most interested in. And I believe you've had some discussions with him on how our relationship with AWS affects some of those things. So this is all in that vein. And we know you're a small team and doing a lot of work. So there's also trying to understand the current state of things, what's planned, what's not planned, and maybe figure out ways that we should help to both, make sure our business is, represented in the shared output or the open source output, as well as drive through some of our priorities that we've talked about with AWS. Does that make sense?
Yeah. Yeah, that totally makes sense. And I'm talking to Alex and I'm talking to Vijay, so I'm on the loop and I know what we're working on. So first of all, I will say that on my team, we actually have Joe Kelly here, and he's going to run this team as a lead. And we're going to, as you can see, there is more people from Solo here on this right now, and mainly because there are going to be way more resources going through this project. So we are growing dramatically right now, and specifically a lot of them is going to this project. So what I wanted to say is that that next on our list, we already had support for AppMesh, and I think RV is here, so we can talk about it a little bit more. And now, as you guys probably know, STO is not as AppMesh is not as mature as STO yet. So, I mean, so that will be the next thing that we're going to add. But to be fair, it's going to be a little bit challenged, mainly because, you know, they're not supporting all the feature. I mean, Scott, maybe you can talk about it a little bit more about because you looked at it.
No, I don't. I mean, we know AppMesh's maturity. I mean, when we talked to them, it was interesting that they didn't, you know, because they didn't even have MTLS. Some of the stuff that we
Right,
wanted to talk to them about, they said, "Oh, we don't care about that because we don't have MTLS yet." So it was kind of.
I know. So that's exactly the problem that we had before when we tried to do the federation. So we said, but they don't even have MTLS. So what is to federate it per se? So Scott is here, and the way we build the federation objects, and they can talk about it more, is the fact that it's easily can be added. And that was our purpose of doing it. So right now we did it for S2 and to S2, which would make a lot of sense. And we had it working with Linkerd and so on. But maybe Scott, you wanted to kind of like give a little bit more
Yeah,
input
I
on this.
actually just checked the AppMesh docs, and it looks like they finally added support for MTLS.
Oh.
Is it MTLS or regular TLS?
It says encrypts communication between the Envoy proxies.
Yeah, it's not MTLS.
Is it not?
I don't think so.
Well,
we can double check.
know,
But
I know from discussions. Well, actually, I better not say what, because I'm not sure what's covered by NDA or not. So never mind. I'll take back what I thought I was going to say. I'll take back.
Well, anyway, there's a certain set of requirements that are needed in order to essentially there's
Wait, I just wanted to say something. We are actually, Cisco and Solo is under NDA, but I think there is other maybe people here. So maybe we
yeah,
can,
this is a public call though, so let's.
yeah, that's a public call, so let's
public,
take it off.
Yeah, it's a public call, and I was specifically referring to conversations I had with AWS that I shouldn't share.
Yeah, we can take it offline because between us, we do have an MTLS. Hey, MTLS, we do have NDA, sorry.
There are models for doing it. There's something called, we refer to as shared trust and limited trust. In order to have sidecars from different meshes communicating, we need to either establish shared trust, which means a shared root certificate, as well as a shared concept of identity between the meshes so that policy can be applied. If AppMesh is supporting MTLS, it means that, and they allow you to configure the root certificate, it means that we can accomplish shared trust, but accomplishing shared identity might be more challenging, so that applying policy in that model might be constrained. However, there's another approach called limited trust, which is a bit more challenging to implement, but it's on our roadmap, and it essentially employs using a gateway as the intermediary. So we can configure a gateway on each side, which will negotiate the switch in trust, which means the switch in trust domains, the switch between the MTLS, the common shared root, as well as the common concept of identity across meshes. And so even if we can't get to a shared trust model working for AppMesh because of what the limitations on what they support, I'm pretty confident we'll be able to do a limited trust model, which anyway we plan to support moving forward. So there's a fair amount of work involved, but it's definitely doable, and the current system takes into account, you know, that this is where we want to extend to.
I just posted a link, but on July 13th, AppMesh added a virtual gateway. So that should allow us to configure ingress traffic to AppMesh compute environments. I think Alexander mentioned this like the second or third meeting.
John, is that helpful? Do you understand what we're trying to do here?
Yes, actually, I wasn't gonna. We've talked before about we're very, very interested in the limited trust model and seeing that. So that's something we've brought up in the past, but I wasn't gonna, you know, hit on that again here because I know it's coming, work in progress.
Yeah, so we're working on this, but we put all the stuff in place right now for that. So to add it will be extremely simple. That's part of the refactoring that we were doing. Okay.
So Mihai, I cut you off a little bit. Was there anything else you wanted to add on your specific topic?
No, no, I was just wondering where the status was with AppMesh and what still needs to be done to provide that full integration so we can get a better idea of what's going to happen and maybe plan out if we can help with that integration. That's what I was going for.
Yeah, that will be very, very useful. So as I said to you, I kind of like feel specifically because there is some, and then maybe we should take it offline and talk a little bit about, you know, how we can actually collaborate and split the work or something like that. Is that something that will make sense?
Yeah, I'll try to, I'm also, I didn't realize Vijay was going to be talking to you so soon. I'll try to talk to him a little bit about, you know, about this call and what we discussed. So to prep him a little bit. So that would be perfect.
Fantastic. Yeah, that sounds good. So perfect. And yeah, so as I said, I mean, the team is going to grow dramatically right now. So we'll have way more people on this. So we'll be able to help you guys more. Awesome. Is there any other thing on the docs?
We've got a comment, the question from Dominic from last time that we didn't get time to discuss. So Dominic had asked, hi.
Yeah, cool. Actually, you will see that that question goes very much into the direction of the initial topic that John brought up in the very beginning. So, but to keep that open-ended, my question was, so the current implementation of Service Mesh Hub uses a pull model. So there are components deployed on the management cluster. There are components deployed that reach into the other clusters in order to discover the meshes, services, and workloads. And I was wondering why you made the decision to have a pull-based model instead of a push model.
Scotty, do you want to take it? You're on mute.
I'm sorry, could you repeat the question?
Yeah, I was wondering why you have a pull-based model where components in the management cluster and the central SMH cluster reach out to the other clusters for discovery, and not a push-based model where you have components in the other clusters that push to the SMH cluster.
There are a number of benefits to doing this. I think the foremost is that there's just less components to deploy. There are less potential things that can fail. We know, for example, if we can't reach a cluster due to network connectivity issues, we are, you know, we have a single source of truth. We have a single master cluster that we can look at in order to say, oh, these clusters are reachable, these ones aren't. I think in general, we've found that when doing a discovery approach, a pull model tends to work better. Yeah, there's also things like permissions, you know, it's easier for us to, like, we already need write access, right? We need to push the output configuration to those clusters. So that means that we have to give permissions to our master cluster in order to do so. It's just easier to also give the master cluster pull access rather than to give sort of a reverse directional push to the managed clusters, access to push into the master cluster. These are some of the reasons behind that.
Understood. Yeah, the reason for that question was when I think about extensibility. So right now the service mesh hub is let's say fairly intimately aware of the service mesh implementations like Istio and Linkerd. I was wondering if there is at least a possibility to plug in an API, whether now the component that discovers the services actually runs on the satellite clusters or runs on the central management cluster, would then be a flexibility, but at least talk to the API to tell SMH about the discovered services, because that would be a natural extension point, right? Where if you have different registries or whole different setups, that you have a component next to that setup that just pushes the information via a standard protocol into SMH and basically tells SMH about the services.
I don't think that it actually should matter too much in terms of, you know, is the data being pulled or is the data being pushed? I think what matters for this use case is simply that we have a generic API that can be used to discover like arbitrary resources. So if you wanted to place like some generic CRD that represents my custom mesh into that cluster, Service Mesh Hub can still discover that, you know? It's not so much a question of which direction the data is flowing, but more, can we work with a type of data that's not mesh specific? Does that sound?
And yeah, and you could even have a mix and match, right? Where it's like you have default things like Linkerd and Istio, and that just runs on SMH Hub because technically, yeah, it's a plugin, but we set it up so that it is part of the core solution. Whereas if you have some on the fringe meshes, then you can run that on your cluster.
Yes.
However, the one thing that I would that I want to stress that is a little bit off, not completely off topic, but a little bit out there, is that if we open that up, right? So to the like the API basically that any mesh can just create services and workloads and all of that. There should be a very well communicated and very well defined notion of what a service actually is. And I know that John is just about to strangle me again, but I'm not getting tired to repeat that if you ask 5 people what a service is, you will get 7 different opinions, right?
I think that we try to go within Service Mesh Hub the approach, which is that a service is an endpoint that receives traffic. So it's an HTTP server or gRPC, maybe UDP or whatever, but it's a server. It's the recipient. We ultimately map mesh services to a host name. I mean, that's really the key. So host name being the recipient for traffic, and then a workload would be the client. So I think we do have the basis for a pretty concrete abstraction. And then depending on, you know, the type of mesh service, whatever the actual concrete implementation is, we've got, you know, in our protobuf schema, the ability to add concepts for whatever. So we'll definitely, sounds like we'll be adding console will be the next, you know, we'll have a mesh service that can be backed by a console service entry, and you know, we'll be able to fetch that data from console, or static endpoints or another one that sound like seem to me, you know, another extension point there.
Are there then additional guarantees around that? For example, if I have 2 different clusters and the management cluster, but cluster A, cluster B, cluster A can reach the management cluster, cluster B can reach the management cluster, that as long as A and B can reach the management cluster, A and B can call all services if they have the permission and they have guaranteed reachability?
Yeah, so the way that it works, the way you would do it today is you would register cluster A and cluster B to Service Mesh Hub. Service Mesh Hub is going to go and discover all your services in there. Then you create what's called a virtual mesh. The virtual mesh is a group of meshes to treat them as one. You would create a virtual mesh that encompasses both cluster A and cluster B. You'd set a policy there that says allow federation, allow services to talk back to each other. Service Mesh Hub will configure the underlying mesh resources so that requests can reach each other via a globally available DNS name that we publish.
And that is a guarantee?
Yes.
Cool. And then also, is there a guarantee of name stability, that the service is available under the same name everywhere?
Yes. So currently the naming convention is when you register a cluster, you register the cluster using like a Kubernetes compatible name, which is a DNS name. And then we create a suffix. So it's going to be the service name dot the service namespace dot the cluster name. And you should be able to reach that service, call it from any cluster that's in the virtual mesh.
Okay. Yeah, I would suggest that basically all of these attributes that contribute to the service semantic, that they are documented well, right? Because I mean, the industry will never agree on what a service actually is, but at least in the context of Service Mesh Hub, we probably should.
I agree. And one other thing I wanted to say, just going back to your comment about the pull and push model, just to be clear, discovery happens via a pull model, but if you want your cluster, any client you want, you can manually create those discovered resources. They don't have to be generated via discovery. So if you want to build a client that's going to push discovery resources into your master cluster, that's entirely possible to do.
So would you, that is actually cool. If you allow me one follow-up, would you suggest that that goes via the standard Kubernetes API of basically create, update, delete, and then custom resources, or should that be different, basically like encapsulated in something that in spirit is close to like XDS of Envoy, where you have a gRCP protocol that exposes these objects and operations?
It's a good question. Right now, everything is based on CRDs. I really prefer CRDs because of the tooling around them. So you've got everything from API versioning to admission control to being able to use kubectl for debugging. We have sub resources, so you can look at the spec and status as independent fields. Resource versions in order to prevent write conflicts. You know, there are a lot of benefits for information that's being fed to the control plane being stored in the form of CRDs.
Yeah, I have no argument there. Same. And just one more question, super detailed. I'm sorry for that, but you were talking about reachability. That the master server is basically reachability is expressed from the observing point of the master server. So is there a guarantee that the master server can't reach cluster B, that then cluster A will not be able to reach cluster B as well? Will that be propagated?
That's a good question. So if the master cluster can't reach one of the satellite clusters, then we won't be able to configure that cluster to receive global traffic. So I think what we're best suited for is intermittent connectivity. So if we drop connectivity to that cluster, but the satellite clusters still have connectivity to each other, as long as they've already been configured and nothing has changed, then you will have, you know, persistent connectivity. But as soon as we need to control something, we need to update configuration on a satellite cluster. If we can't connect to it, then there will be, you know, a loss of connectivity for that period. And there are strategies for mitigating that. We haven't gone too deep into it, but one of the nice things about Service Mesh Hub design is that anything can be technically considered a master cluster. So at a certain point, if we decide we want to install, you know, distribute Service Mesh Hub instances across each satellite cluster in order to ensure that we'll never have a problem with a master cluster, in single master cluster failing to have connectivity, we can do that.
Oh, now you're okay. Eventually, we gotta brainstorm about that, because now you're totally talking my language. Since we're already into cluster federation, we basically also need to get into Service Mesh Hub federation, and then stuff gets really interesting.
Yeah, so part of the approach in the design is that Service Mesh Hub should run, you know, the same regardless of where it's running. You can even run it locally. You just need, what you really need is a common bucket of CRDs, all the CRDs that Service Mesh Hub uses to represent the state of the world. So as long as that data is available, whether it's replicated across clusters or centralized in a master cluster, Service Mesh Hub should have the same result. But there's a lot more details on that. We can go into in another session.
Cool. Thank you very much.
Yeah, and Dominic, I just wanted to add that we also have, we're going to improve dramatically the docs right now. So we're going to have someone dedicated to writing docs. So I think you will see the docs getting way better. And we will be able to write more the implementation details. So. Awesome. Is there any other question or requests?
Yeah, that was everything that was in the notes.
I think that's it from our side.
I had
everything.
I had one question. Can you hear me?
Yes, Pavan.
Yeah. So when I was actually going through the code where SMS does service discovery, I found that you actually check if a service is actually backed by a workload and reject the service if it doesn't have an actual workload. I just wanted to see if that's the right approach, because a lot of the Kubernetes services have some have selectors, some doesn't have selectors. Endpoints is a good example. So wanted to know, is there any plans to sort of update that, or does that work for all the SMH use cases?
So in the refactor, that assumption has been removed. It's still a requirement for subset selection. So if you want to route to a subset, you want to do like a traffic shift. Subsets are based on those backing workloads. That's how we partition a service. But we can support external name services, headless services, and that'll be part of the benefit of switching to the next. We'll probably be doing a pre-release based on the refactor within. I don't want to give a timeline, but it'll be soon.
Perfect. Thanks.
One more thing that we're going to do that I don't know if it will be specifically interesting for you, but we're also going to release a UI. So I think that maybe will be something that you might be interested, mainly a read-only UI that will give you a good way to kind of like see if something wrong, kind of like a dashboard. So, because the way our resources is always working is there is kind of like a notification if it's accepted or denied, or there is any problem. So all of this is going to propagate to a very good, kind of like nice UI that's showing, all the upstream, all the policies and everything that is being not in a good state. So you will immediately be able to go and basically debug it and understand what the problem in the mesh itself or in the federation. So that's coming up really soon too.
All right. If there's no other questions, then we are just a few minutes before the end of an hour. So we can anything else that comes up, we can kind of add it onto the list to next time. And we'll see y'all in 2 weeks. All right.
Thanks.
Thanks
You.
all.
That was good.
Bye.
Thank you.
Thank you so much.
Thank you. Bye.